So thank you everyone for joining us today. I'm Renata Kalniūnienė, Marketing Project Manager at MedDream, and today we have a joint webinar with our partners, AWS, and our webinar is dedicated to MedDream Viewer integration with AWS HealthImaging. And today we have a special guest from AWS, Adam Kielski, Senior Solution Architect, Medical Imaging, and our CEO, Tomas Dumbliauskas, who will together present this great integration. The agenda is short introduction of our collaboration, integration presentation, workflows and use cases. Of course, the most interesting part, live demonstration. Our guest presentation of AWS HealthImaging, their solutions overview and architecture, and the question and answers part, where I'm going to read all the questions we got before the webinar and all the questions we will receive during the webinar. So as I mentioned, the main speakers are Tomas Dumbliauskas and Adam Kielski. And also today we have our special guest from MedDream side, Artūras Gruodis, Head of Integration Department, and Lemm, Business Development Manager for Medical Imaging Innovation at AWS. They are going to help us in the question and answers part, helping to answer your questions. So, Thomas, I think we could start. I'm handing the presentation for you.
Hello, everyone. So thanks again for joining our today's webinar. And Renata, thank you for introduction. I will share my slides. So it's actually one of the main reasons why we actually started our integration between MedDream and AWS HealthImaging, because in the past years we see really growing demand of cloud-based solutions. So many of our customers are actually more and more moving to the cloud, and our customers expecting actually scalability, security, certification, and easy access to medical images. And AWS actually can provide a powerful infrastructure, and MedDream can provide an efficient viewing experience. So this is, good match. First of all, I like to present this general diagnostic workflow and how in this workflow can be deployed, can be used AWS HealthImaging, and how can be used MedDream as a viewing component. So everything starts from the diagnostic data. So usually locally in the hospitals, in the clinics, there are a lot of medical devices. Maybe there are different departments with different devices. It's a lot of modalities which generates usually imaging data. All this data is stored locally in local network, in some PACS systems, VNA systems. And if we are talking about some cloud solutions, so this data should be sent. So usually use some uploader or gateway which enables to send this data to the cloud. And here we're talking about a storage component, AWS HealthImaging, which you resolve the storage, what the customers can store the DICOM data with AWS service. And then MedDream purpose on that to view this data. So MedDream goal to provide a visualization component with all these vendors, which, for example, develop this series HR systems can integrate MedDream and view the data. Actually, many of our current partners or current customers already use AWS system and as an infrastructure, and they use, for example, as free services they use EFS service for storing the data. And they use also MedDream. But now when it's AWS HealthImaging available, so of course we like it to provide additional option for our customers. So this integration already works with the newest version, which will be available in 2 weeks. So 8.6, MedDream version 8.6. And if we are talking about our roadmap, about our goals and potential values, so I like to mention what we can achieve in the future. So one of the key technology benefits of AWS service, what it stores lossless data in high throughput JPEG 2000 format. So that means what data stored compressed in the service, and we're thinking how to reuse this benefit in MedDream. So our goals in the next version, what we would like to stream the data through AWS directly to front end and skip the backend processing. So in such case, we think what it will be possibility to reduce infrastructure complexity. Also, we will reduce the processing amount, because if it directly data will be streamed directly to front end, that means less data will be processed in our backend. Also, performance improvement. So now usually for MedDream, we recommend the preparation service, which prepare data for the first opening to be as fast as possible. But if we will stream this data directly to front end, that means we can even skip this backend. And it seems like performance can be similar or even better than we're having now. Reliability. So here I would mention what actually we, for last 5 months, we're working closely with AWS team to make sure that all the data, all different types, all the modalities, transfer syntaxes, SOAP classes, correctly stored in the AWS HealthImaging service and also correctly visualized. So it's everything about the quality, what we like to provide really highest quality solution for our customers. Also, we improving our knowledge, MedDream team knowledge, and our next goal to provide some documentation, some instructions how MedDream can be deployed in the cloud with AWS integration. Also to have some recommendation how MedDream can be optimized for cloud usage. Fast implementation. So it's everything about development. So if our most customers developing some solutions, and for example, if they need a storage solution, if they need a visualization solution, so of course they can reduce the amount of development hours needed to implement the solution by using our services. And to summarize what is already available and what is will be available in the future. So actually here it's MedDream part, here's AWS HealthImaging part. So actually MedDream in MedDream version 8.6, getting data by native HealthImaging API and also by standard DICOM web protocols. Reprocess this data to our native formats and stream it to front end, and there visualize the data to the user. What is the plans? The plans for the next versions. So I would say this plan for this year till the end of the year. We're planning to do support of high throughput JPEG 2000 format to stream it directly to front end. So we, as you see here, we will skip the processing, skip the caching, but in such case, of course, we will need to decompress data in front end and then only then visualize it. What is still missing in current implementation is storing annotations and secondary capture. So even now, I would say it can be used with some additional services, but in the future versions, of course, it will be straightforward solution, what is needs some configuration, and that's all to store all these additional data which can be generated by MedDream itself. So this is our current situation and the plans for the future. MedDream can be used with two options. One option to use not only MedDream viewing window, but also search window. So the user can log in by the user password, can select even storage and see all images in one storage or in all the storages. It depends on the permissions. And then click on the study to open exact studies he selected. So it's one option. Another option is mostly used, I would say, what MedDream can be integrated by secure token-based integration. So it can be integrated by study unique ID, patient ID, accession number, and some combination of these parameters. So all these integrations, as described in our integration documents, it's already tested and work with our latest version of MedDream. I like also to show some use cases, how MedDream can be used in some situations. For example, here we have like AWS HealthImaging service, and there are some organization, maybe some locations where the images are located and sent. So it can be set up one storage or multiple storages for all images. And here for visualization, for example, we can integrate MedDream and define different rules. For example, if it's integrated from external information system, so it can be some rules what one doctor can access, for example, images only from one institution, or maybe another doctor have a right to access images from different institutions, from different storages. So this is for image sharing, remote consultation, probably this scenario can be used. Another scenario is disaster recovery solution. Let's say in hospital, there is a lot of devices, and of course, ongoing diagnostic process. So let's say the customer decide to set up the backup solution. So images not only go to the local PACS system or local VNA system, but in parallel go to AWS HealthImaging, and it stays the data as a backup. But what happens if it's some disaster happens? That means that the user cannot access images from the PACS, but if it's his system have a link to cloud-based MedDream installation, so the users can actually access the images from the HealthImaging. Another situation, maybe the users cannot access all local systems. Maybe then it's provided other cloud-based solution, which provide possibility just to access data through MedDream also. In this scenario, also very important, the storage tiers. So Adam will also present this functionality in his part of presentation. Now I'd like to show short live demo. So I will share my screen. So it's actually configured HealthImaging in combination with the MedDream. I put a user password. I can select a storage. Let's say I can select here, we name it the storages some modalities. For example, I click for some CT study and it opens. So actually this site is deployed in USA, in US East 1 region, and I am opening these images in Lithuania. So it's really quite fast. Of course, here is CDN configured. That means what if I already open it, these images before, so they streamed quite well. As an example, I will try to open some ultrasound. So here we see what is primary study CT, what I opened it, and here I see ultrasound, which also was opened in the second panel at the right. So yeah, I don't like to go to all the functionalities because all the features actually working, except some small exceptions, like as I already mentioned, with storing data, secondary capture, which is will be next version, but actually all the MedDream functionalities, it's working quite well. So this is all of my presentation, and Adam, please, your part.
Great, thank you, Tomas. Hello, everyone. It's great to be here. Let me just start the sharing component of my slide deck. All right, great. So hi again, I'm Adam Kielski, Senior Solutions Architect in Healthcare and Life Sciences at AWS. I've been working in the medical imaging field for over 20 years, managing enterprise imaging and healthcare solutions, imaging systems deployment and management, as well as integration with medical services and cloud-based imaging. So today I'll be talking about the AWS HealthImaging service, so you can have a better understanding of how established medical imaging solutions like MedDream are leveraging its capabilities to enhance their platform. Switch slides here. So AWS in healthcare addresses three critical challenges in modern medical imaging: accessibility, personalization, and cost efficiency. We bring over 15 years of cloud leadership to these challenges. And it's really not just about infrastructure, it's about understanding the unique demands of clinical workflows. So our dedicated healthcare practice, now in its 8th year, combines cloud expertise with practical healthcare experience. Our leaders average over 18 years in healthcare and life sciences. And we're working directly with the systems and workflows that are used in medicine on a daily basis. So this expertise really helps us develop solutions that accelerate the digital transformation while maintaining the performance and reliability that clinical care demands. Let's go to the next slide here. So as AWS, we support healthcare innovation through two complementary approaches. For builders, we provide direct service access and control. So if you take MedDream, for example, as an established viewer with FDA clearance and CE certification, they've integrated AWS HealthImaging to enhance their platform's capabilities while maintaining the proven viewing features and workflows that they've already built. On the other side, we have for buyers, we offer multiple trusted partner solutions built on AWS services. So when customers fully implement a solution like MedDream Viewer with AWS HealthImaging, they can access enterprise-grade image storage and management while preserving their existing clinical processes. So this allows tremendous flexibility. So we've developed over the years 4 specialized services that transform healthcare data management. AWS HealthImaging as a DICOM storage service forms the foundation for medical image management at petabyte scale. So it handles everything from traditional radiology to advanced imaging modalities, enabling solutions like MedDream to provide seamless access across these specialties. Then we also have AWS Health Lake, which provides a complete view of individual and patient population health data using the FHIR standard, and it provides API-based access to that clinical data. We have some new services, AWS Health Omics, which processes genomic data. So that enables precision medicine and further enables the multimodal analysis of health data. Finally, we have AWS HealthScribe, which completes the picture by automating clinical documentation, so reducing the administrative burdens on healthcare providers. So Together, these purpose-built services create a foundation for modern healthcare delivery with over 130 HIPAA-eligible services. AWS enables healthcare organizations of any size to enhance patient care while maintaining the security of that data as well as the compliance requirements. So let's look at some numbers that, being in the industry, you're probably well familiar with. So the scale of medical imaging presents pretty unique challenges. So if you consider that 30% of all digital data is clinical information, and of that, around 90% of healthcare data by volume is imaging related. So with the amount of procedures being done annually, over 5.5 billion at last estimate, and each of these studies on average being around 150 megabytes in the radiology space, organizations really face a lot of challenges for that level of data management. So, you have sort of the whole gamut of examples, with typical CT studies, being in excess of 500 images, digital pathology slides easily exceeding 1 gigabyte per image. Then you have additional derived data done with advanced visualization. And of course, you have to have the ability to load prior comparison studies instantly with the study that's being read. So, purpose-built solutions really matter. And it's why a partner like MedDream is able to leverage health imaging to handle this scale effectively. Line here. So health imaging is specifically designed for builders developing cloud-native medical imaging solutions. So let me talk about some of its core capabilities. The service ingests data in DICOM Part 10 format. It converts it to high-throughput JPEG 2000 for efficient storage and ability to stream data. And then finally, the service provides APIs designed for sub-second retrieval of the metadata and the pixel data in the studies. And you can do that together or separately. So a key advantage is the ability to run multiple imaging applications from a single authoritative copy of the medical imaging data. So this eliminates the redundant storage of many copies. And as you know, these copies may simply be different in their metadata due to perhaps de-identification for a research project. So this really ensures consistency across all of the different systems that are accessing this data storage. Let me talk about how it works a little bit more. So the workflow would begin, with your existing imaging infrastructure. So a PACS, VNA, medical imaging modalities. So AWS HealthImaging receives these images and automatically optimizes them for performance and cost. So the data through essentially any storage solution that you may have would currently land in an S3 bucket. You would programmatically trigger the health imaging API to ingest that data, and it will provide you details and feedback on how that data was stored, as well as the metadata around that study. So from there, you can build and deploy AI/ML solutions. You can enable collaboration and sharing if you have, for example, a patient portal. And you're able to access images through clinical applications like MedDream, and this is all while being able to maintain integration with your existing systems. So, with this collaboration with MedDream, they've demonstrated the workflow in practice. So they're providing the users of this viewer rapid access to images, while health imaging's underneath is handling the underlying storage optimization. So this is a little bit more about the architecture. So organizations will typically see around 40% storage cost reduction compared to a typical on-premise solution for medical imaging. So this comes from the ability of AWS HealthImaging to intelligently manage that storage and automatically tier it. And I'll talk about that in a further slide. So sub-second image retrieval is maintained regardless of location, and you're able to do that directly through the APIs, or should you wish to incorporate a CDN like CloudFront, as MedDream has done here, you're able to further deliver that image data very rapidly to regions throughout the globe. So high throughput JPEG 2000, which is the compression format that we use to store the data, is a lossless compression technology you may have heard of already. It is now part of the DICOM standard, and it ensures really efficient storage as well as the speed of access and clinical quality that's required. One of the tremendous advantages of HTJ2K or high throughput JPEG 2000 is that it's approximately 10 times higher performance from a decode and encode perspective. So when you're doing all of this in a browser, it's much more efficient. So here are some of the use cases that we primarily see in medical imaging. So we have enterprise imaging, which enables organizations to store and stream the image data directly from AWS while maintaining that clinical required performance. We also see a lot of long-term image archival that is able to deliver cost savings while maintaining the sub-second retrieval times that you really want to have with your archival storage. And it really removes that compromise that you may have to make either for inexpensive disk and slow retrieve times, or high performance expensive disk and high performance retrieve speeds. AI/ML analysis capabilities also allow organizations to run artificial intelligence workflows directly on the imaging archive. So this enables advanced analysis without having to move the data or duplicate the data to another storage solution. And then finally, multimodal analysis, which I mentioned earlier with genomics, that allows you to combine imaging with omics data and health records in HealthLake, for example, to enable precision medicine initiatives and really a comprehensive insight into the medical record. So one of the interesting capabilities of AWS HealthImaging is that it optimizes storage costs while maintaining clinical performance. So we maintain really throughout the lifespan of the study that is being stored, we implement intelligent tiering with a clear life cycle. So images start in our frequent access tier, as you see in the slide, at roughly 10 cents per gigabyte per month. So that ensures performance for active clinical use. And this is where all of the studies that would typically arrive from a PACS or from a DICOM modality would actually land in this storage tier. After 30 consecutive days of that study not being accessed, it is automatically tiered to that system. It is automatically transitioned, to the archive instant access tier at approximately 0.6 cents per gigabyte per month. And that really makes this solution quite interesting. So unlike traditional archives, these images maintain their sub-second retrieval times throughout the storage. It doesn't matter if they're in either of the tiers. So there's no restoration process. You don't have to wait. There's no different retrieval fees. It's just always available. So now I'd like to just go over a little bit more about the MedDream solution that was implemented with HealthImaging. So the integration of MedDream with HealthImaging leverages several key AWS services. Oops, apologies. my sharing stopped. Let me try that again. Sorry about that. Let me fix that. Okay, hopefully that's working again.
Yeah, we can see.
Thanks for the comment on Chime. We'll get there. Okay, there it is. All right. So the MedDream architecture, we really started this whole journey along several paths. As you can see in the image here, we initially took the approach of ensuring that the solution is running as a containerized system. So we're running MedDream as containerized tasks within Amazon ECS, or the Elastic Container Service. And that's also running with the Fargate launch solution, which allows the system to automatically provision the right type of compute resources based on the need of the application. And at that point, we integrated the application load balancer to dynamically balance the load between those instances of the MedDream Viewer, with CloudFront sitting in the very front of the system to be able to cache the image data closest to the end users. So all of that with the MedDream backend connected to HealthImaging through its APIs to be able to retrieve the image data and then present it to the users. You can see here in the bottom, there's the S3 standard bucket. So that's what I mentioned. The DICOM Part 10 files would land in S3 and subsequently be imported into AWS HealthImaging.
The first one, when will this be available?
Yes, so as I showed the slide, one of the slides showed the situation, what we already having in the newest version of MedDream. The newest version 8.6 will be available after 2 weeks. So it will be possibility to use MedDream in combination with AWS HealthImaging service. And of course, as I showed our roadmap, so definitely we will implement some news in other versions, future versions.
Okay, next question. Where do we see possibilities to generate business?
I think also we already fulfilled that question, because we showed from MedDream side, we showed some scenarios where this solution can be used. It's AWS HealthImaging, and with scenarios can be used also MedDream, and this integration, how it will be used. So I think we also fulfilled this question by our slides.
Okay, thank you. So I'm moving to the next one. Will the integration of MedDream Viewer and AWS HealthImaging be bundled as a service available in the AWS marketplace?
Yeah, so our main goal actually to improve our documentation. So we're thinking, as an example now, to deploy newest version of MedDream to Docker Hub as a Docker, which can be used to deploy MedDream. And we like to have some configuration files which can be used for the deployment. In the future, we're thinking about instructions, how manually to deploy solution. Next step would be some script which could automate the deployment, and these scripts probably could be useful for our vendor, for our customers, which can modify the script and adjust on their needs. And of course, the latest, most easy solution, it would be like to deploy MedDream to AWS Marketplace, where, as an example, potential customer can just click the button and deploy all the solution in most simple way. So it's in roadmap, but most probability what will be it will be at the end of the year.
Okay, another question regarding microscopic imaging. Does MedDream support digital pathology?
Yes, MedDream currently support only like a separate image viewing, and it's actually not as expected by the users of pathology. So it's still, I would say, it's not supported by MedDream. We have it in the roadmap. We have this pathology viewing. We're planning to implement it. Actually, most important would be to have a good partner, good customer, which will adjust our functionalities, what is really need to implement for the end user. So good partner, good customer can, I would say, speed up our development. So because depend on the commercial terms, definitely we can include this functionality to the next versions. And maybe Adam, maybe you can provide some comments on the health imaging support of pathology.
Yes, I can. So AWS HealthImaging does support the storage of digital pathology data. Now, mind you, it's with HealthImaging being a DICOM storage solution, that pathology data needs to be stored as a DICOM format rather than one of the proprietary formats that may be in use out there. So yes, we do support it. That is actually one of the reasons why the system uses high throughput JPEG 2000 because of its progressive loading capabilities that are a big advantage with digital pathology. I see in here there's a question about viewers, any recommended viewers. We have partners who are working on this.
How to upload data to AWS HealthImaging?
Mm-hmm. So as I mentioned during my part of the talk, the way that data is currently uploaded is you would store the data to an S3 bucket, and you may do that through a file upload tool if you have a storage gateway solution that you use as part of your DICOM traffic. That gateway would be able to store the data to the S3 bucket, and then you would trigger an API call from HealthImaging that will ingest that data. So that's the mechanism to store data currently. We are working on future support for STORS as part of the DICOM web standard.
Okay, thank you. I'm reading also a question about uploading. In your scenarios, how are images being transferred to AWS? You mentioned uploader.
Mm-hmm. So we, as I said, the way that the health imaging system works right now, the service ingests data from an S3 bucket. So really, it would be up to the integration of any DICOM gateway that you may use right now to be able to store its data temporarily to S3 and trigger that import command.
But perhaps I can also elaborate a little bit on that question, which I think came from John Bishop. So thanks for asking that. As Adam said, this year we will also support STORS later down the year so that you can directly import it. In addition, what Adam said, when it comes to the gateways, there are several third-party DICOM gateway providers already today, giving you the option to import the data like Dicomatics or also Lara Imaging. We also provide open source projects for around AWS Health Imaging, which includes a DICOM listener, which you can actually implement to import the data. So I just shared the GitHub repo here. And for anyone interested in mass migrations, for instance, if you would like to move your long-time DICOM archive to health imaging from on-prem, we also provide special tooling from a service team perspective, which is not documented, but this tooling is available to make it really easy for you to upload everything at scale if necessary. And if you're interested in that, please reach out to me and Adam for the details.
Great,
Okay,
thank you, Alex.
Thanks, Alex, for adding. Another one, how to deploy your presented solution.
So maybe Artūras, you can comment what help we can offer for our customers.
Hi. Once 8.6 will be released, so in principle, we will create a separate page in Docker Hub with the instructions how you can deploy the solution by yourself. In addition, you can always contact our support or integration team, and we will help you, like with any other integration we have.
Yeah, if I could just add to that, as part of the work that Artūras is doing, we will eventually be able to provide a CDK deployment, so a scripted deployment of the demonstration that you saw today into AWS.
Yeah, in longer run, we will have the script. At the moment, it will be with Docker.
Okay, thanks. And the next question kind of overlaps, yes? Who can help me with the deployment and configuration?
Yeah, we already answered it.
Yeah, you can always contact either integration team or support team, and we will help you.
Okay, another one. Our attendee asks, so I can get rid of my actual PACS provider and replace it with MedDream. We are already on AWS with our hospital IT infrastructure, but our PACS provider don't want to support AWS as free. Who's going to answer this one?
Artūras, maybe it's to you some usual question about some new integration and how we can help in this scenario.
So in principle, the first thing would be to find a good solution how to move data to AWS HealthImaging, and there are plenty of options as we discussed and Alex presented. So in principle, first of all, we need to agree which solution will be suitable in your current infrastructure, and afterwards it's just installing MedDream and configuration. It's straightforward.
Okay.
So basically, we need to find a gateway, first of all, which would allow you to send the current studies, configure modalities to send the studies to the new gateway, which will upload the data automatically, and we need to migrate all the data as well.
And maybe one more thing, as I see here about don't want to support. So it depends, of course, on the region. Do we have any vendors actively working in that region? For example, if we already have customers, vendor, which is already doing business in medical imaging field, so of course we can redirect you to the best of our customers, which can help you with the support. So this is also the solution how to, for example, to have best possible support.
Likewise, on the AWS side, we have multiple partners who have built solutions directly on AWS services that would be able to take advantage of MedDream as a viewer. So that would be a way to, potentially transition your data to a system that is natively functioning and effectively functioning on AWS infrastructure.
Okay, so I'm reading the next question. When will the new release of MedDream be available?
Yeah, so we're planning to release at the end of next week. And actually, we're planning to have like webinar functionality, webinar next week, so you can join and see the newest features which will be available in this new version.
Okay, thanks, Thomas. Another question. Does AWS HI require storing images on S3 permanently or just temporarily to get to AWS HI?
I can take those two questions.
Thanks, Alex.
Yeah, thanks, Adam. So I think we answered the first question in depth, right? So the default mechanism is to use a temporary S3 bucket, and again, you don't need to store the data there permanently. It's just like for the import, but also the other mechanisms are available, like this year StoreRS support, third-party DICOM gateways, mass importers, and last but not least, the open source projects we published via our GitHub repo centered around the DICOM listener. So those are the primary solutions there. I see like the next question is about GDPR and storing data also from German customers. So the answer to this is yes. So in general, our services come which we released are GDPR ready. That means they are not by default GDPR compliant, because you, as the user of those services, you need to ensure that you use additional services to make your entire application layer and GDPR compliant. That means, for instance, for storing patient data of a German patient in the cloud, you need to ensure that, for instance, the data is encrypted. However, in our ecosystem, we provide all of those services that you can actually create your application in such a way that it is GDPR compliant. If we now take it one step further, if you are even interested to use any of those services as part of a SaaS solution in Germany, whether it is S3 or AWS HealthImaging, starting July this year, you would also need to have an additional C5 Type 2 certification from a Wirtschaftsprüfer, so from an auditor, on application layer level. This is something you need to bring and work with the auditor. But it's not something we can provide to you. So, however, we provide all the services that ensures that you can make your solution GDPR compliant, and of course, then also C5 Type 2 compliant. And if you have more questions around GDPR hosting healthcare data, especially in EMEA in Europe, don't hesitate to reach out to me.
So thanks for the questions. I'm moving to the last slides, in which we want to invite you to meet us in person. As you know, next week it is the biggest show and exhibition in Europe for radiology, ECR. So welcome to meet MedDream in our booth. Write us to the email and we can find the suitable time for you. And also you can meet AWS team during February 26-28 on site. There is a link where you can book a meeting with them. So please contact and let's meet in person, continue our discussions. And 1 week after, we are having also exhibition in USA. So both MedDream and AWS have booth there. So also please contact us. We can schedule a meeting, and our MedDream team and AWS teams can continue on cooperation. And also, as Tomas mentioned before, next week we are organizing a webinar for new upcoming release of MedDream. It's been quite a while after the last one webinar, so wait for the news. It will soon be published, the webinar event, and we will wait you next week to join us. And also, I want to remind you that this webinar was being recorded, and all the registrants and attendees will receive the video recording probably next week, the presentation file, and all the questions and answers. So thank you, everyone. Thank you for joining us. Thank you for our speakers, for our partners, and I hope that everyone had a productive time. I think presentations was very interesting. So see you on our next events, and have a good day or evening for everyone.
Thank you.
Thank you, everyone.
Thank you.
Thank you.
Thank you.
Bye.
Bye, everyone.
Bye.